Hi everyone, we are back, and today we have Michael Richardson from the NASA Armstrong Flight Research Center Enterprise. And welcome, Michael.
Hey everybody, how's it going? This is Mike from sunny California at 6:45 in the morning. Got my coffee, so I'm so excited being here. I can't wait to give you guys a really cool presentation on what I got here. So I'm ready, man.
Great. Michael, I mean, today is a very interesting day for us, and I'm sure most of us will be, so keen to hear from you and what you have done in NASA. So yeah, please share your screen with us.
Okay, let me do that. Let me go ahead and hope everything works great here. Pardon me if I have any technical. Cool.
No, that's fine. Perfect.
Yeah. Well, if I got the floor, so hey everybody, I'm Michael Richardson, and I am so excited to be here. And I just kind of want to give you a little background on myself here, who I am. So what I do for NASA, just to let you know, I'm an enterprise data pipeline solutions architect. And so what my role is to let me step back a little bit. So these projects that we have here, we've got like Sophia, we've got like DC-8, we've got like ER2, and they have these really crazy systems inside of them. And so think of it this way. I know everybody's flown an aircraft, right? So think of an aircraft where all the seats are stripped out of it. And that's kind of weird, right? You'd walk in an airplane, there's no seats in it. So, but what they do is they install these crazy racks in there. And these crazy racks have all these instrumentation that they put in there because they do a lot of what's called airborne science. And airborne science is, for example, the one I'm going to talk about today is the DC-8. And the DC-8 is like super bad. I mean, they've got it like they have these two lasers and they have them attached and they're on the other side of the wings and they shoot them down at the density of ice. Now, I really don't know for sure if, the global warming thing, I mean, you guys are way smarter than me, but all I know is they fly these aircraft, for example, the DC-8, and they do missions, to example, for like, they go to fly to Chile and they go fly up to the Arctic area and they do a lot of research. Now, a lot of the research is actually spawned by a lot of universities all over the world. So when they came in to me and they said, Mike, we want you to build these crazy architecture systems for us that connect all these different legacy systems. And I was like, man, I'm down, man, because that's kind of where I want to go. I want to be the kind of guy that can build and pull all these systems together. So that's why I am the enterprise solutions architect for a couple of these projects. And I better get going here because you know me, I can run on forever. So what I'm going to discuss today is, like I said, you've got the DC-8. It's an airborne science laboratory. It's just a DC-8 aircraft, and it's kind of old, but NASA does a really good job of continuing to maintain these aircraft. We have a great maintenance crew. We have great operations crew and pilot crew. They're the best in the world. That's all I can say there. So like I said, they came to me and said, Mike, we have a challenge. We need to collaborate all these systems that we have. We need to somehow take it from, for example, a maintenance system over here, a system we collect science over here, pull them together because, we got to know what's going on prior to flight. Sort of like the shuttle, right? I heard this funny thing where when I used to work for the space shuttle program at NASA before, you have like a panel of like 30 people and they sit there and they go, okay, is it ready to fly? And they'll suddenly go, yes, 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 no. And they're like, what do you mean no? So it's like you have a lot of coordination that's going on, right? You have a lot of people that you have to have all these systems working. And that's the thing about how NASA is and a lot of these other organizations and the government. You got to have all these things working, especially in our digital age today. So again, I'm going to talk about this one particular system that I built for the DC-8 project, and it's called the DC-8 portal. I'll describe the features of it, and then what I'm going to do is I'm going to get into the capabilities. Now, I'm going to show you a crazy homepage. Don't laugh at it, because at NASA, you got to understand one thing here. We build systems. We build them for functionality. We don't build them a lot for like, man, dude, that's good, for some websites. We try to as much as we can, but we try to build them mostly for capability and functionality. So
Gotcha.
what is support, right? That's important, isn't it? Because
Very
could you
important.
imagine? I mean, serious, man. Could you imagine the fact that, Mike, you forgot a breadcrumb over here. I forgot a what? I mean, who cares about the breadcrumb? You care about the data it's pulling in, right? So, okay, I got to tell you, man. I'm sorry, man. You got me on jokes. One of the data managers up at Ames Flight Research Center, she calls me on the phone, man, and she goes, I just cannot believe where we got to put those breadcrumbs. And she says, I couldn't sleep at night. I'm like, what? You can't sleep at night because you're worried about where the breadcrumbs go? Are you serious? And I'm working on the Sophia aircraft, and we're talking about pulling in telescope data, and she's worried about the breadcrumbs. I'm like, man, there's something wrong here. But that's my point, right? I was serious. Yeah, it's crazy. And so the point is that that's how NASA is. And we try to stay focused. Focus on the data, man. Focus on the mission. And that's what's important. So that's kind of where my talk's going to go into, because the DC-8 ops engineers came to me and they're like, man, we're doing these inspections. And in these inspections, we're starting to get pushed back. And I go, well, why are you getting pushed back? Well, it's because we have all these documents that we got to go through to find, for example, a valve or whatever that valve is, and we can't find it. And it takes us days to find it. I'm like, oh my gosh, I can build you a system to be able to do content search where I can take you where you type in that valve and I'll take you right to the document. And we're talking thousands and thousands of documents, and I can take you right to the page and the occurrence of it. And because of that, they've been able to meet a lot of their inspections now. So, I mean, that's right? That's the intent, right? Is that you are to meet the user's requirements. And that's what's really important. I also want to show you how NASA's been really good to me through the whole evolution of enterprise architectures, to where we started out looking at models like web services in the beginning of it. And I have an example there too, where the Sophia project came to me and they go, oh man, we got to change our database. And we have it connecting this portal and we don't know all the exits and entries and interfaces. And we got to connect a new, it was going to be an Oracle database to it. And we got to get you to program it. I said, stop, let's build as a web service. Let's build as an interface in between the databases and the portal. So from now on, if you ever change the database, right, that way, you won't have to worry about this massive code change on the front end piece, and there'll be no interruption. And because of that, it's been very successful doing that. Again, I'm going to show you the content search, the evolution, and this super big bad thing I found called Apache NiFi. One thing I want to say here, I'm a geek, right? You guys know that by now, right? Because the way I talk, I just get real passionate.
My partner Dunstan is on this call as well.
Yeah, well, I thought about it. I did. I thought about this and I said, you know what? I'm going to be the geek guy here. The guy, the computer geek guy, tech guy, and I'm just going to go with it and, just see how it goes. Let me continue. So this is, if everybody can see it, is the crazy aircraft. This is the DC-8. It's an airborne science laboratory. And like I described before, this baby here has all the seats stripped out of it. It's got racks inside of it. And these people come from all over the world, these universities, because they do their research in it. And I don't know all of it, but I love this down here at the bottom. You have archaeology, ecology, geography, hydrology, all the ologies. It seems like all the universities, seriously, man, all the universities come in here and they like to do their ologies. That's what I call it. So you can see this is a very important aircraft for NASA. And then you look at it going like, dang, Mike, that thing looks old. It is old. So you need a really good crew to take care of it. And that's the maintenance side. So I'm trying to build everybody up here thinking about, my gosh, what kind of system are you talking about here? Because
how old is the system of this plane?
Yeah. And the thing about it is I'm going to show you a crazy picture next here. And look what this thing serves, this portal. You got engineering, and that's a whole battle, right over there. You got logistics, the parts, like, I got to change a tire. Okay, where do I go to change the tire? I got flight. In flight, you're collecting data, right? And then how you collect it. And the aircraft itself. In fact, they've told me the system that I built, they want to load it on the aircraft, and they want the pilots to be able to access their flight manuals in flight, which is really cool. And that way they don't have to like go through this. I'm like, really, you guys still, or they have iPads, but then they're like, on an iPad like that. I'm like, dude, I can build you a system.
Can you fly the plane like looking at the iPad on how to fly?
I have no idea, man. But yeah, could you imagine? It's like a game, right? And you're playing a game, and like, oh dang, I gotta find out, if that stick, it has the right ratio. Here, let me go. Oh dang, I gotta go to this manual. So the point is that you want to build a system that collaborates all of this. And then I put weather in here because it really does. They want to find out prior to flight if the aircraft can fly or not, especially when you get in that super cold weather. I was just talking about something in Ukraine, and they're like, man, it's cold here. So when an aircraft is going to fly, you got to de-ice the wings, and they got all the preparations. So I'm just trying to build everybody up here to tell you that this DCA portal is pretty bad. And what I mean by that is it goes and it connects. It's like I said, it's a data pipeline connecting to all these different data sources. So what is this features of a DCA portal? Well, it contains also an enterprise architecture over here that connects to all these other legacy systems, which I explained. And it does a lot of sharing of the data. And I'm going to get a little geeky techie talk here. I heard a talk earlier somebody talked about, and it talks about big data. I'm going to say what the impact has been on NASA for big data. Before it was structured, oh my gosh, Rico, I'm telling you, they would come back and they would ask you to put another column in a database. You're like, you want to what? I'm like, because it's a lot of work when you have a structured, tightly coupled, front end to a back end database. But then somebody came along and made big data. And I love this analogy somebody gave. It's like a card system. Remember the old card, you flip the thing, put the cards in, and you can write on any little line you want. That's the flexibility of big data. And because of it, we have projects now that are just exploding in flight data. Flight data is very unique in itself. You can have different parameters, right? And I was thinking about some of your talks, and I was thinking, man, you can use this even in quantum, when you're colliding and doing quantum physics study.
Exactly, right.
Yeah, you got it. And that's why Mongo, actually, I went to one of their discussions about it. And so it gives you the flexibility when you do these particle collisions like at CERN or this kind of physical type of studies. Now, everybody, please forgive me. I'm not a scientist, okay? But I'm telling you that these kind of systems can be built to where they can handle that demanding need of millions and billions of these document records. And I am so glad that big data has come out because you can see the evolution of it. Yeah, and it's been able to handle all those demanding needs, because I've been hearing a lot of your talks and I'm like, yeah, they're missing the data management side of this, because we all have documentation, right? I mean, you got, Sally or Dave over here going like, dang it, where's that part for that quantum computer? I'm just saying. I mean, so everybody needs, a good documentation system to be able to find their parts. And I'm going to move on and you have to tell me when to quit. So the enterprise architecture, it contains a data pipeline architecture. It's event driven, and it uses, and some of you out there that know about IT, it's called Apache Kafka. Now, when I mention Apache is like an open source community that I go, thank you, God, because I can go to my management now and I can go to them and say, I have this prototype that I want to build, and I don't have to sit there and ask them for a lot of money for my prototype and research. And so what open source has done is giving me that capability to be able to prototype and do trade studies without minimal cost. And I just am so glad for it. And because of that, you got Apache Solar. You have, for example, this Apache NiFi, which I'm going to show later, which was actually purchased from the NSA. Yeah, the NSA, that our national safety, whatever, in the government, they built this so it's secure. And I have actually, I'm running the same demo I did for the Air Force. I did about a year ago. and they really liked it because of the security that's built into it. So I'm now going to get into and dive in a little bit into kind of what documents do I support right now for the DCA portal. And so what I have is what's called the AMM. It's an aircraft maintenance manual. And that's the one where you have the tire, I need to change it, what does it look like? And then what's called an IPC. And an IPC is, for example, the parts catalog. It tells me that part number for that. And then what you have is a structured repair manual. And that kind of is more detail about how to change it. So now you're starting to go, wait a minute, there are a lot of document types that you're supporting in the system, and that's correct. And then so you have all the metadata now that's involved in that. So what are the capabilities of the DCA portal? Exactly what it says here. It retrieves, for example, from NAMUS. NAMUS is an aircraft maintenance system that's at Johnson Space Center. It was built about 10 years ago, and it'll tell you about the status of the aircraft. It'll tell you about the status of the engines. It'll tell you about the service serial numbers on the engines and how many hours the aircraft has flown. If the aircraft is ready to fly, it's either green, up or down. And for example, the DCA is going through some engine problems, not problems, but maintenance right now. And so if you were to go on this portal right now, you would see it's red down, and then you would notice that some of the engines, they're kind of removed from it because they're going like, okay, engine's out, so we won't fly it. And I know that sounds funny, but I heard about in the Air Force, this poor pilot got into his aircraft. He tried to turn it on. It has no gas in it. And you're like, what? How can you sign up an aircraft with no gas in it? I'm like, oh my gosh. Well, that's what the maintenance system does. It just makes sure that the aircraft is ready to fly and everything is signed off. Another thing that the portal does is it contains all the news and alerts to all the users, like, is the portal up? Is the portal down? What's going on over here on the project? It's kind of a collaboration tool, sort of like a wiki, right? Because you got to know if the pilots are ready. For example, the ops engineer is ready, for the aircraft to take off. And then, like I mentioned, the weather, also security. And that's a big, big deal here at NASA. I mean, so many people are trying to hack into our system. Yeah. And so we use the same thing as the Air Force. We use a system called CS SiteMinder, and it's a card authentication is what it is. It uses Kerberos. And so you have to have a card, and then you sign into the system, and it allows you access into the system. I just want to throw this out there. We can access, and we do, to SharePoint. That's our system we use for our collaboration tool, where we might load some documents in there. We also have areas where our projects have their meeting minutes, things like that. Another system that I've interfaced to working on Sophia project is Windchill, and they store all their documentation in there. And so you're starting to see the power of this thing. And I love giving this demo because they go, oh my gosh, we can connect to this. You're right. And also you can connect to Jira. And if you're in software development, Jira is a tool you use for agile development, and it allows you to track your development. But Sophia uses also for their operation of their telescope. So when they fly Sophia, they'll enter their information about operation of the telescope, what their findings were, things like that. They also, the flight crew, which is like the engineering crew, they'll use that system to fly, like, we flew at so many feet or whatever, and what they do. Another thing I want to touch on, it's not localized at Armstrong Flight Research Center. This spans across multiple centers, and that's the beauty of it. In fact, I touched on that earlier. NAMS is a system at Johnson Space Center in Houston, Texas, and I'm out in California, and it's immediate response. That's what I love today about the way we can collaborate and pull these systems together and be able to retrieve the data. Okay, this is my shameless pitch here. This is the front page of our portal. Now, all you web developers out there, all you great UX designers, please give me a break, okay? It's 6 or 7 o'clock in the morning. But this is the page that we use to be able to come in here. It's a one-stop shop, and be able to come in here and link. Yeah, it really is. It's a place where everything drops in, and you're able to click on links. You can see, I know it's out of date. I get it when I took the snapshot, but it shows you this is on a mission right now. The next mission's coming up. Here's the news notes I talked about. Here's the portal hours, you know, in the portal, because again, I'm sure all of you gone out to Amazon or whatever, and he goes, you know, we'll be back in a few. You're like, we'll be what? I want to find this part, or I want to find this item in Amazon or whatever, but they're doing their maintenance in the background. And that's why you want to notify the users when we're up or when we're down to come access the system. Then you have aircraft documentation. That's the documentation tree to where you're able to select a particular document that you want. Operations is the one, and I think that's my next page. And I'll go to that now. This is the one I told you about. This is the page where we're connecting to Johnson Space Center and to that NAMUS system. And you can see right here, it's down, and it's telling you I'm down because there's something in the aircraft maintenance system is saying, you know, Mike might be pulling a tire or a rudder or whatever, and it's telling you that the system is down. And once everything's been signed off and it's ready to fly, it'll be green and ready to go because it's passed all pre-flight inspections, and it's also had everything, you know, gas in it, you know, things like that. The beauty of this too, I pulled in, like I said, the flight hours, the cycles on the aircraft itself, the serial numbers, you know, cycles, how many times you spun those engines, right? You turn them on, and they're all up on this particular screenshot. So in a way, I hope that, yeah, oh man. So think about it. If I have a quantum computer, all that crazy stuff I got, it has to be operating, right? You could build you a dashboard for the quantum computer. I mean, all the particular items that are critical for you, because I'm trying to pitch my talk towards, you know, what really your forum is about. And then, so a little bit more now, I'm going to get into the documentation store and content search. And it's really what it does. It extracts the different types, and they're called SRM, Structured Parent Manual, IPC, which is that parts catalog, contains all the part numbers and different types. The format we use is PDF. You know, everybody likes PDF, yay. And that way, that you're able to access those. And I'm serious, man. I'm talking, when I came in over here, they're like, they have this thing on their laptops, and everybody had their own laptop. And I'm like, no, wait a minute. Yeah, where's the configuration control? Seriously, how do you know that what Bob's got on his laptop is the latest compared to what Sally's got on hers? When I look up at your landing gear, right? You got to be using the same document. You have to, because, you know, Bob will go out and go, that's not what it looks like. And then Sally goes, yeah, it is. No, wait, I had version 3.0 and you had 3.1. So there's a configuration control that's here. And oh man, hey, by the way, everybody, it's our secret, right? Don't go back to NASA and tell them what I'm sharing with you. I'm gonna get so much trouble, man. No, seriously, it's just a story, okay? It's not true. Anyway, I better continue on really fast. So
5 minutes.
Okay, yeah. Okay, thanks. Pretty much the system, it allows you to be able to connect the systems, and I better move on. So this is the search capability right here. And for example, I'm doing an engine nose cow search here, and you can see where it brings back the results here. And this is the super bad part, man, because I selected it and it took me right to the instance in the document. And that's important because not only does it take you to the document, it takes you right inside to the content of what that particular search you're looking for. So now you start to see, no, wait a minute. When you're talking management, you're talking time and savings. And this is where the system is really paying off now, because it gets them right to the instance of where that particular item is. And it allows them to be able to perform their maintenance, which is really what it's about when they're doing a phase inspection. And I'm going to fly through. Here's another one. Here's another example of a parts catalog here. And you can see where they wanted this particular item here. It takes you right to the part. And here's another search here that you're doing. And then this is the evolution of where NASA has gone. This is actually Sophia. This has been published now. If you want, you can look up my name. You can, Richson NASA. There's more information on this that you can look for. This is more of a service-oriented architecture of what it is. This is the one right here that we're still in the process of building. I'm trying to build you up real quick because I'm going to show you where everything is going to. This is the game changer, man, because there's no more, I need the guy that works on the interface in between the component. I got one guy sitting there pulling down these processes right here, where you install a MongoDB database or a Solr database. And now I just go on a website and I start to connect the dot. It's awesome. You start connecting everything together. And I actually have resolved data issues, conflicting issues, and incompatible data right here, implementing a filter on the fly, which means there's no code change, there's no implementation cycle, nothing. And so this is a really powerful system. And if I got a couple seconds, I had an interview with the airline company. I'm not gonna say who it is. And they came to me and they said, man, we need search analytics. I go, you mean you don't have that? I mean, this is a big airline. They go, no, we forgot to put it in. And I said, I know how to do it. I was able to drop this Mongo in here like that and be able to now take that data and push it over here to these processes, massage it, and dump it right into Mongo. It took, man, it took me like, I mean, seriously, I could have done this probably in a day. And they were trying to figure it out how to do this. And that's the power of this, is that you can start to connect all these different systems like from the process. And this is what Apache NiFi is. And when you look back at the evolution of, I'm gonna go back real quick. Look at the difference here. I mean, I need a lot of programmers right here to support all of this right here, don't I? And even connecting all of these. And when you get to this, it's like you just need one guy, man, sitting behind, you know, his keyboard, and he can connect all these up. It's a game changer. And this is why I wanted to bring this to your conference and show that this can even be used for future space exploration, because everybody needs to connect the data. It is freaking awesome, man, because it allows you to focus on what your mission is and just hire the right skilled people to be able to maintain this. And so that's why I've been building this up for everybody, because I wanted to show you, like in a, I don't know what you call a crescendo, I think you call it, where you were going up, right? And then boom, we come down, because this is what this is. And when I saw this, I was like, oh man, this is cool, because this really now gets to focus on the data itself, collecting the data, the science it needs to collect, right? And so it's super powerful. I'm not going to get in deeper dive. If anybody, if you want to talk to me, you can, and I can share more about the technologies that we're using. This Kafka is real hot right now. You probably asked me, what about the cloud? Yes, I didn't touch on it, but that's where Docker comes in. It containerizes the software to where you can put it like in a, you know, a little container and then shove it up to the cloud. So this is building you a cloud capable system. And then so here's the Mongo real quick. I was able to implement this really fast now to do search analytics for the DCA portal. And then let's see what else. Oh yeah, and that's pretty much about it. I mean, this is my shameless, you know, awards. I'm sorry, and that's about it. And then my big blob questions. Sorry,
quick one, just a quick one. What do you tell the kid who is wanting to do something in the space industry? What do you tell them?
For space industry, you know, I thought about preparation for this forum, right? And it's funny you say that, because that was I knew the question was gonna be asked to me. I think a system like this, everybody needs it. I mean, everybody has documentation, and it seems like when we were designing our flight data portal before, I mean, you're getting, yeah, we're gonna connect this and this, but then you got, well, what about the metadata? You have metadata, man, and you got to have it to where everybody can search everything that they need to, right? They need to be able to search anything they need to at any time, especially when you get advancing into your project. And so what's important, don't forget about documentation. Don't forget about the metadata. What do I want to search down the road in 20 years? Because another project I'm on, Sophia, it's been going a long time now. And you know, you're off doing something else. And the thing about it is, you know, they're expecting you, whatever you developed 10 years before, right? That they're still able to get to that documentation. You also have a record retention. How long do I hold these documents to where they're usable, right? And so all this needs to be figured out real early when you have like a space exploration project. Just because it's going into space, it doesn't mean it's not going to have documentation. And that's kind of, that's a great question, because we can't forget that. We really can't. So that's my answer.
Thank you, Michael, and thank you for being here with us. Though it's short, we have lots to catch up, and have a nice one over there, okay?
Yeah, guys, thank you very much. Sorry I took so much time.
No worries, it's all good. Thank you, man.
Yep. Bye.
Bye. And we'll be back in 1 minute. See you guys. Right, Michael. Awesome. It was good.
Thank you, sir. I just, coffee, and it's 6:45 in the
Hey,
morning.
coffee. I'm having like KFC.
What? I need to.
Yeah.
I need
It's
to.
like doing this thing. This is going to be a 15 hours thing for me, nonstop. So,
I know, dude. I know, dude. I saw you in the beginning. I'm like, he's gonna do the whole thing. Oh my gosh, you're gonna need like coffee and everything.
But anyway, I'll talk to you soon, Michael. I have the next speaker coming in. Okay?
Yeah. Thank
Take
you.
care.
Thank you. Bye, sir. Bye, bye. Yeah, high five.
Bye.
Yeah.